What if AI that's quietly making decisions about your life has hidden flaws? A flaw that could potentially cost you your job, a loan, or even mess up your healthcare records. Now, this is not a science fiction concept, it's a reality of AI bias, and that's one of the biggest problems in the modern technology. For years, trying to fix it was like performing a surgery with a sledgehammer. But what if someone finally invented a scalpel? Researchers at MIT have developed a technique like a data sniper to surgically remove the bias without tanking the performance of the model. We're going to break down how this trick works and what it means for the future of AI, and look at how one company is going to use to make their algorithm faster and even better than before. Every single day, AI systems are making judgment calls. They are sorting through resumes for recruiters, mortgage applicants in the blank. They're also looking at and helping the doctors to spot the specific diseases. The whole promise is the world which is perfect and unbiased. But there is a catch. The systems that these AIs are learning from come from our world. And our world always has been and always will be full of biases. So the AI that is trained on decades of hiring data might just learn that executives are usually men and start discriminating against women who are as qualified as men. And AI is going to train on medical data from one group of people, might just make flat out dangerous predictions for everyone else. The problem is the AI doesn't think. It just recognizes these patterns and then it applies the patterns to do the analysis. If the pattern and the data are biased, AI becomes super fast, automated way of repeating those biases on a large scale. It builds an invisible wall, quietly reinforcing the old inequalities. For years, this left developers with a massive dilemma. The obvious fix seemed to be just like find the data, right? Make it fix. And that's not that easy. The go-to approach was rebalancing the data set. So if 80% of the data comes from one specific group and the 20% from the other, you could try to even it out and normalize it. But that's clumsy. That's like a sledgehammer approach because it often means that throwing valuable parts of the data, which can whack the AI model's accuracy. So you might just reduce a little bit of bias, but you could also break the model and make it pretty much useless. So the choice is between a biased model that works or a fair model that does not. Now, let's get into the old methods and why it is so frustrating. The sledgehammer approach that we just talked about, which is data balancing, comes in a couple of different flavors. So one is undersampling. When you're just deleting a majority of the data from the minority group. Imagine you have like a library of 1,000 books and only 100 are written in the last 10 years. So to balance it out, you will have to throw away the 800 books. Think about all the knowledge that you're going to lose by throwing those books away. In AI, this is kind of the data loss that can cripple the model's ability to make accurate predictions about anything. The other method is oversampling, when you just copy paste the data that you have from the minority group. Now, this could potentially help a bit, but it usually leads to a problem is what is called as overfitting. Now, AI gets obsessed with few specific examples that it has seen over and over, and it cannot learn the general pattern anymore. It's like studying for the final exam and just memorizing 10 questions. Now, you're going to be really good at answering those 10 questions, but you're going to fail the exam because all you focused on was those 10 questions and you were not prepared to answer all the other questions. So the developer now, they were smart people and they tried something different. What if we can just hide the sensitive data from AI? Now this is creating what is called the bias blind model. If you don't want the AI to bias based on a specific race, you just delete that race completely from the data. You remove that column. Problem solved, right? But it's not that easy. Now this fails because something that is called as proxies. Proxies is a piece of data that seems totally neutral, but secretly it is connected to the data that you're originally trying to hide, which is race in the previous example. Your zip code, your name, and the stores that you shop at can be a powerful clue about your race, income, and social class. The AI is going to hunt for these patterns and they're going to find the backdoor and is going to ignore, you're going to ignore the race, but it's going to learn from the people from certain zip codes are less likely to get a loan. And suddenly you have the exact same bias all over again. It's kind of a game of whack-a-mole. You smack down one source of data and AI just finds another source. Let's talk about the scalpel, the MIT data sniper. Now, this is a nightmare that AI developers have been living for quite some time. But the breakthrough from MIT has completely changed the game. They finally moved beyond the sledgehammer to introduce the scalpel. Instead of just blindly balancing the entire data set, which is the example that we talked about previously, their method acts as a data sniper, finding very specific items and removing the specific individual data points that are teaching the model to be biased in the first place. So the brilliant part of that is not all data is created equal, and we know that. Some of it is helpful, some of it is neutral, and any tiny specific number of data points can be actually very toxic that are poisoning your AI and causing it to fail on that minority group. The researchers develop a method using a tool they call it TRAK, T-R-A-K, which can literally trace a model's mistake back to the source. It analyzes AI's wrong answer for underrepresented groups and then figures out the individual example in which the training data was responsible for those specific errors. So think of this as an example. You're training a quarterback, a star quarterback in the American football by showing them thousands of films of the game. But the hidden in the footage are few clips where a brilliant creative play somehow leads to a disaster event at the very next touchdown. Now your quarterback sits up and his thought is, well, creativity is risky. I can't do that. That old method would be throw away half of the game clips. But the MIT method is to find those very few misleading clips and just delete those clips. The quarterback keeps all the knowledge, but unlearns one bad lesson that was holding him back. This data sniper approach is a game changer for two reasons. First, it is incredibly precise. In one test, as a matter of fact, MIT method actually boosted the accuracy for worst performing group while removing about 20,000 fewer examples than the older sledgehammer approach, which is pretty substantial. This means that you can fix the bias without destroying the model's overall accuracy. Second, it can even find hidden biases in the dataset that are not actually labeled. In the real world, well, we all know that the data is really messy, making it an incredible tool for finding and fixing bias that nobody was thinking that existed before. Now, the ability to surgically remove these biases like this is a massive leap forward. It is a move away from clumsy compromises towards a future where AI can be both powerful and fair. Now, if you're really excited about this, as I am, as you can see, where ethical AI is headed, make sure you subscribe to my channel, you hit the bell icon so you don't miss next what I'm going to be sharing. So what does this look like in real example? Let's talk about a practical case study. It's 10 p.m. in a gleaning headquarter of a financial company, let's call it FinTech Forward. The office is dark except for the glow of one single monitor. A young data scientist is running one final check in their new AI, a model that is designed to approve small business loan. And they're going to be launching this model next week. So right now, they're just going through a formal procedures to make sure everything is good. But as the results scroll across her screen, she leans closer and her heart starts to pound. This can't be right, she thinks. The numbers look terrifying. The next morning, she's in a conference room with the leadership team. She's trying to keep her voice steady, and she says the AI is rejecting the qualified applicants from one specific minority groups at 5 times the rate of everyone else. The room completely goes silent. The launch pretty much is dead at this point. Suddenly, the company is facing a PR nightmare and a crippling regulatory fines. It's kind of the full-blown crisis. Their first instinct is to try an old method. So the team starts to work around the clock to fix it. They're trying oversampling, which I explained earlier. The result, the AI gets fairer, but the overall accuracy drops significantly. Then they try the bias blind model by stripping the demographic data, which also does not work because the AI latches onto the proxies, which is the zip code of the business supplier, and the bias roars back in. After the week, the team feels defeated. We can feel the tension in the room. The shoulders are slumped, the faces are pale, with exhaustion. Then the lead data scientist finds the research paper from MIT. It is a long shot, but it's worth taking. He walks over to the terminal and starts implementing this new data sniper approach. They feed the training data and the model's bias decision into the system. So the algorithm starts to run, and when it's finished, a single number appears on the screen, 1.5%. That's the amount of data that is flagged as toxic. These were sudden hidden poison pills. One was, in fact, a successful businessman who just missed one single payment last year, and their location was teaching the model that all businesses in that neighborhood were higher risk. With a mix of disbelief and hope, the team removes that slice of data and retrains the model. They run the audit again. There's a collective gasp in the room. Why? Because the fairness gap, that massive difference in approval rate, has dropped significantly, in fact, by 80%. But then comes the real game changer. The model's overall accuracy has barely changed, decreasing by less than 0.1%. The lead data scientist leans back on his chair and takes a deep breath that he's been holding for a long time. They finally did it. They have achieved the incredible fairness without sacrificing the model's performance. Now, for FinTech Forward, which is this company, the data sniper is the hero. But the real world, a turnaround like this requires more than just a silver bullet. The data sniper is your star player, of course, but it needs a great supporting team like any other team. A truly responsible company would combine the surgical power of data cleaning with the whole toolkit for building fair AI. One of the most important tools in your toolbox that you should have is called explainable AI, or XAI. These are the techniques that let you look under the hood of a complex AI and understand how and why it's making the decision that it is making. After the FinTech Forward retrained their model, they would use XAI tools to double check that it was now focused on legitimate financial factors like cash flow, business plans, and not sneaking in proxies for the demographic or that specific zip code. Now, it's a crucial layer of transparency that allows the company a key piece of continuous monitoring tool where AI bias is not going to be one and done. So you have to constantly look at the problems. So models can typically drift over time as new data come in. A fair model today can be biased 6 months down the road. So companies need an automated system that is constantly testing for bias, acting like a permanent guardrail to keep the things fair. And finally, the technology itself is half the battle. The best effort of fighting the bias involve diverse and multidisciplinary team. This means that not just having a data scientist in your team, you need both ethicists and social scientists as well. And in fact, you also need the people from the community that AI will be actually impacting. Think about that as you're conducting a marketing survey where you're interviewing the actual local people in that specific market. These different perspectives are essential in spotting the kind of subtle but the real world biases that data alone can never show you. Now, AI bias, in my view, is one of the biggest challenges of our time. And breakthroughs like the data sniper technique from MIT is going to show us the new way forward. Now, what do you think about the biggest hurdle that is truly impacting the performance of AI? Let me know your thoughts in the comments. And if you want to explore the hidden risk of AI that most people are not seeing, check out my new video that's called The Hidden Risk of AI That You're Not Seeing. That is going to be showing up in the screen